Hi there, welcome to EduretiX, where we make your high school life simple. I'm Aniket and I'm here with the second part of the Kinematics practice series for AP Physics 1 and GCSE Physics papers. So in this part, we're going to do questions exclusively on graphs, so graphical analysis of velocity time, acceleration time and displacement time graphs, and questions related to that. So make sure you keep practicing alongside. Whenever there's a new question, pause the video, first practice it yourself, and then only look at our solution. Let's begin. Okay, so let's look at this question. In section 5 of the velocity versus time graph, the object is, and then there are 4 options given in which the options are describing whether the object is slowing down or speeding up and whether it's in the positive direction or the negative direction. Okay, so instead of solving just for section 5, we'll look at all the 5 sections and analyze what kind of motion the object is undergoing, okay, just for practice. So let's see. Section 1. In section 1, you see constant velocity because magnitude is not changing. It's a straight line against the y-axis. So constant velocity is one thing. And it's in the positive region. This is positive, this is negative. That means it's traveling with constant velocity in positive direction. This is section 1. Let's take section 2. Section 2, we see the magnitude of velocity is decreasing, but it still stays in the positive space. That means it's slowing down, but the velocity is still positive, slowing down in the positive direction. So what's happening from 2, it's like the object is moving like this with a slowing down velocity. At a certain point, it will take a U-turn, start moving in the negative direction. This is positive, this is negative. So as soon as the third region occurs, you see the velocity is increasing in the negative direction. So it's speeding up in the opposite direction compared to its previous motion or compared to section 2. So it's speeding up, but in negative. Speeding up, negative. Now section 4. Section 4 is similar to section 1. So constant velocity in the negative region. So this is constant velocity in the negative region. Okay. Section 5. Let's see. In section 5, it begins with the velocity at which section 4 ended. That's some magnitude. And it's approaching a zero velocity. That means it's slowing down in the negative direction still. So it will basically make a crossover. The graph will make a crossover from what I can predict, depending on what we saw for 2 and 3. So it'll also happen like it's moving here. So this was section 1, constant velocity. Then the velocity increased in this section, section 2. Direction changed and it moved. Section 3, again constant velocity, section 4. Now for 5, it's slowing down, will come to a halt and then take a turn again. This is 5. So it is slowing down in the negative space. So slowing down, moving in the negative direction. Option D, that is the correct answer in this. This is how we analyze the motion given through a graph. Okay, the next question. This question is really important from the AP Physics 1 and GCSE Physics perspective, and it'll belong to the hard category of questions. So let's see. If the particle begins its motion at t is equal to 0 with v is equal to 0 and x is equal to 0, make a graph of velocity versus time. Okay, so the particle is starting at t is equal to 0 with 0 velocity, and there is 0 acceleration all the way up till t is equal to 1. That means between 0 and 1, the velocity is going to be 0. First thing. Okay. Now, at t is equal to 1, there is a sudden acceleration of 3 meters per second square with initial velocity 0. So after 1 second, what will happen? The velocity will increase by 3 meters per second, because acceleration is just the rate of change of velocity. So if it was 0, now it will be a positive 3. A 3 would be added. So after 1 second, the velocity would be at 3. Another second, 3 meters per second more added to the velocity. Then another 3 more. Like this, it will keep on increasing all the way up till t is equal to 4. If you want to see v is equal to u plus at, so let's say at t is equal to 3, I want to check. So u initial, it was 0. How many seconds? 2 seconds have passed till t, because motion started at t is equal to 1. So a, 3 meters per second square, into t, 2, 6 meters per second. That's the velocity increase. Okay. So now from t is equal to 4, at t is equal to 4, it has reached what velocity? 3 seconds. So 9 meters per second. At t is equal to 4, it's 9 meters per second. Now, after t is equal to 4, we see a negative acceleration of 2 meters per second square. So negative acceleration means that's deceleration. The velocities will go down. So it'll keep going down by 2 meters per second with every passing second. So at t is equal to 5, the velocity would be 7 meters per second, one step down. 6, it will be 5 meters per second. 7, it would be 3 meters per second. 8, it would be 1 meter per second, and then it'll cross over. At 9, it's going to be, how many seconds have elapsed? 1, 2, 3, 4, 5. 5 seconds elapsed at t is equal to 9. It was at 9, so 9 minus 2 into 5. That's a negative 1 meters per second. And at t is equal to 10, it will be a negative 3 meters per second. So it has reached negative 3 meters per second. Okay. Basically, there has been a change in the direction of motion. Between this 8 and 9 seconds, there has been a change. Since it was decelerating, the velocity first went to 0, then it started accelerating in the negative direction. Okay. So that's what has happened. Now at t is equal to 10, again we see a positive acceleration of 1 meter per second square. That means the velocity will keep on increasing by 1 meter per second with every passing second from here. So negative 3, it was at t is equal to 10. At t is equal to 11, negative 2. T is equal to 12, negative 1. And t is equal to 13, 0. So the velocity comes to 0. This is the velocity time graph corresponding to the given acceleration time graph. This is how you analyze it. Okay. This is how you'll analyze this graph. And also mathematically we can see v, basically a, acceleration was the derivative of velocity, dv over dt. So velocity was basically at. And if velocity is at, that means you can straight away get that signal that whichever quantities are represented by slope of another quantity, so for them on the graph you'll look out for slope. So for acceleration time graph, velocity time graph, you look at the slope of the velocity. So between t is equal to 1 and t is equal to 4, there's a certain slope. What is that slope equal to? That's the acceleration. So the slope would be 3 meters per second, or just 3. That will be the slope between 1 and 4. So that's why that is the acceleration. The slope remains constant between 1 and 4. So if we were to go from acceleration to velocity, we'll do the area under the curve for acceleration time graph. So from velocity to acceleration, you calculate the slope. From acceleration to velocity, you calculate the area under the acceleration time curve. So this is the area. That would be like the total velocity change in velocity. As you can see, it's 3 times 3. This side length is 3, the time is 3 times 3, 9 meters per second. That's the change. So beginning with 0, it'll reach up till 9 meters per second. That's what we did. Okay. So this is both the qualitative and the quantitative analysis of the given graphs. Cool. Let's move on to the next question. Okay, so we're given a velocity time graph in this question, and then there are parts to this. The total distance traveled by the object during the indicated 14 seconds, the total displacement of the object during the indicated 14 seconds. So we need to find the distance and the displacement. The two are separate because one is a scalar quantity, the other is a vector quantity, as you already know. So that's why the difference. Now, the velocity time curve. We already know that velocity is basically ds over dt. Rate of change of displacement, or basically if you want to derive velocity from displacement time graph, you will calculate the slope of the displacement time graph, because velocity is the slope of the displacement time graph. So if we were to do the reverse, we need displacement from velocity time graph, from VT graph. For that, what we'll do, area under the curve. So one was derivative or differentiation, this is integration, area under the curve. Okay, so we'll take the different regions between 0 and 7, t is equal to 7. So between 0 and t is equal to 7, this is a triangle. So the area is going to be half, base is 7 times height is 10, that is 35 meters. This is the displacement in the positive direction. Now in the negative direction, you see between t is equal to 7 to t is equal to 14, there is a trapezium. What's the area of a trapezium? Half into sum of parallel sides. So one parallel side is between 7 and 14, which is 7, and then the second one is between 8 and 12, which is 4. So sum of parallel sides, 7 plus 4 is 11, multiplied by distance between them, this magnitude, this much, this is a 5. So 11 times 5 is 55, over 2 is 27.5. So the total displacement becomes 35 minus 27.5, which is 7.5 meters. Option A. Okay. Sorry. The second question is total displacement. First one is distance. So displacement is 7.5. If we were to find the distance, there would be no positive and negative. Whatever it has moved, the object has moved, that would be counted in the distance. So both would be added up. 35 and 27.5, they would be added up, and we get 62.5 meters. This is the distance. Okay. Now there's one more part to this question. Let's bring that up. Okay, the third part, the average velocity over the whole time in meters per second of the object is. Okay, they're asking about V average. So V average, simple rule, V average is total displacement over total time. Let's do that. So total displacement was 7.5. Total time is 14 seconds. So approximately this is 0.5 meters per second. That's the correct answer. Okay. So keep watching, keep following our videos for more such content. If you want to practice for the AP Physics paper, these are the best questions which we've picked for your practice. So keep following. We'll be starting with laws of motion and the other mechanics topics soon. Yeah.